Good morning, students. Please confirm if I'm audible to all. Good morning, good morning. Okay, so yesterday we have studied the basic introduction of computer networks and we saw some main components. So can you all tell me what are the 5 main components of a network? 5 main components. Sender receiver protocol, medium, and the message. Yes. Okay, yes. So these are the main components. All of you know what is a sender, what is a receiver. We discussed that what are the different types of media also, guided, unguided media. We'll go in detail in the coming lectures. And what about data flow? We studied 3 types of data flow. What are the different types of ways in which a data may flow? Simplex, okay. Simplex, half duplex, and full duplex. Okay, one example of full duplex. What is an example of full duplex communication? Telephone communication, telephone network. Okay, and what about unguided media? Any example of unguided media? See, when you say Wi-Fi, when I say that what is media, unguided media, you never answer Wi-Fi because Wi-Fi is a technology. Okay, I am talking about the medium through which the data is flowing. The data is not flowing through Wi-Fi. So you should be clear about that. Wi-Fi is an example of wireless technology, but it is not a media. The media that we discussed, one of those were radio waves, as some of you have answered, infrared, microwaves. So yes, these are the examples of wireless media. And in case of wired, your cables, be it coaxial cable, be it optical fiber, or your shielded twisted pair or unshielded twisted pair cables. Okay, so today we are going to, then we discussed connections. What are the 2 types of connections? What were the types of connections that we discussed yesterday? 2 categories we discussed: point to point, P2P, or multi-point. And the topologies, as in how a particular device or how different devices in a network are arranged to ensure communication between those. So we're going to go through some of the devices today. The first one is a network interface card. So this image is visible to you. Network interface card, basically it is a physical and data link layer device. You'll understand the meaning of this, that what do you mean by which layer it works on, okay, once we start discussing the layers. So it is used by the computers to connect and communicate with different other devices on the LAN. Now each network interface card, as you can see in the image, at the corner, at the left corner, there is a barcode that is there, okay, and there is some address present on there. That is basically its unique hardware identification number. So any network card, every network card has a unique identification number on it, and that is known as the MAC address of the device. Okay, so whenever you talk about the MAC address basically it is the identification number of your network interface card. Now, in this image, you might see that this network interface card is connected to the Ethernet port. These days, the new updated devices, they do not necessarily have an Ethernet port. Okay, so the network interface card is embedded on the motherboard itself. But of course, every computer will have a network interface card, and its identification number is called as the MAC address. Okay, I hope up to this point it was clear. So you should always know that what is the MAC address, what is the significance of that. Okay, next we come to repeater. So all of these are hardware devices. I think some of you must have seen these also. Uh, Now, what is a repeater? Basically, its job is to regenerate the signal over the same network. Now, when a signal is traveling at a certain distance, the signal might become weak due to any reason, be it the loss of signal or be it some attenuation. By any reason, if the signal becomes weak, so what do we do at certain points, at certain distances? We will give repeaters, okay, so that the signal is regenerated and it does not become weak. And when the signal becomes weak, it copies the signal bit by bit and regenerate it at the original strength. So as you can see in the diagram also. Next is your hub. Now, we talked about repeater. It has generally a repeater has two ports. Hub is a kind of a multi-port repeater. It connects multiple wires from different branches. If you look at the diagram with your left-hand side, in the middle of the topology, there is a hub and multiple devices are connected to it. So this is an example of a star topology. Generally in a star topology, in the middle there is a hub and all the devices are connected to it. Now, as you might read, it is written that a hub does not have any intelligence to find out the best path for the data packet, which leads to inefficiency and wastage. Now, what does a hub do? Basically, it broadcasts. Okay, whichever device is connected to it, it is going to transfer the information to all of the devices, irrespective of whether any device has requested that information or not. So it is going to broadcast the data to all the devices connected to that hub. Now, two types of hubs are there: active hub and passive hub. This you are going to study, and you will tell me in the next lecture that what is the difference between active and passive hub. So note this down, that you have to read about these types of hubs. Okay, now we have said that the hub is not does not have any intelligence. So that is the reason, because it does not judge that which device is requesting the data. So that is why it is not intelligent. And since it broadcasts the data, so there is a lot of inefficiency and wastage of data. Okay, so it cannot filter. Always remember that a hub cannot filter data, so the packets are sent to all the devices connected to it. one amplifies the signal and which one does not. Okay, next device, switch. Now, whatever the limitations the hub has, those limitations are overcome in case of a switch. Now we have written that the hub uh, does the work of just filtering, just forwarding the data, but switch on the other hand does both filtering as well as forwarding. So hence it is more intelligent as compared to a hub. So now I think you can already understand that the switch does not broadcast the data. It only transfers the data to the devices which are requesting that. So as I have mentioned in the presentation, that when a packet is received at the switch, it checks the destination address and only transfers the data to the device which is requesting that data. Okay, so next device is your router. So can anybody tell me how does a router work? I think all of you have used routers. What is the use of a router? Okay, no one. All right. So as you can see in this diagram on the left hand side, this router is connecting two different networks. Okay, connecting LAN and WAN and work on the basis like filtering data, transfer the packets on their addresses and provide path, connecting networks. Okay, so a combination of all of these answers, basically Sanskriti, Jatin, and Ayush. Um, a router, it connects different networks together, okay, and it maintains a routing table. Now, what is that routing table? Basically, it has a record of IP addresses of all the devices. Okay, so from where is the data coming to the router and which device is requesting that data? So based on their IP addresses, it is going to transfer the data to the device which is requesting. So hence it is safe to say that a router is used to connect multiple networks with each other. What is routing? Routing, see, it is designed from the word route. What is route? That means a path. So giving a path to a data packet, that process is known as routing. Guiding the data packet to where it is destined. What is the destination of that data packet? Sending it to that particular device is known as routing. Okay, Ritu? Okay, so up to this point, if anybody has a query, you may ask now. Okay, just a second. Okay, Rohit, I have already answered your query that one type of hub amplifies the signal. I told you that there are two types of hub, active and passive. So that you have to study that which hub amplifies the signal and which one does not. Why is the IP address needed when MAC address is also unique? Okay, see, MAC address is the address of the device. Okay, whichever device is participating in the network, that is the MAC address, while IP address is the address of the network. Okay, so whichever computers are connected in a network, IP address it defines a connection of a network with the interface of a device. Okay, so both are important, both have their own importance. And also these have security reasons also. So whenever a certain you might know that whenever there is a cyber attack, some security threat is there, the first thing that is tried to track down is the IP address of the device or the MAC address of the device. The MAC address used, can we track MAC address? Yes, that is the exact use of MAC address to track down the geographical location of the device. You can do that via a MAC address. Okay. Yes, Prajwal, it is possible to manipulate the MAC address and the IP address of the devices. Yes, but those practices are not considered ethical generally. All right. So now we'll move on to topologies. Basically, a topology refers to the physical or logical layout. Okay, I'll take these questions towards the end of the lecture. Okay, I'm just noting down all your queries. Okay, so a network topology basically it refers to the physical or logical layout of the network, that is how the devices are connected to each other. It defines the way different nodes are placed and interconnected with each other. Here nodes, I think you have studied graphs in data structures. So nodes in this case it refers to different devices. Okay, it is an application of graph theory wherein communicating devices, as I have already mentioned, are called as nodes, and the connection between those devices are known as links, or the lines between the nodes, as in a graph you say that the edges, those here are known as your links. Okay, so the first type of topology is your star topology. So generally in a star topology, all the nodes in the network are connected in a central hub to a central hub or a switch via different cables. Okay, so if one node fails, it does not mean the entire network will fail. Like in this case, different stations are connected to this hub. So if one station fails, it is not going to have the impact on rest of the stations. But if the hub fails, if the central device fails, then it could lead to the failure of the whole network. So this topology is one of the most common because it is very easy to implement, but it does have its limitations. That is the one that I have discussed, that failure of the central device can lead to the failure of the entire network. Okay, next is your bus topology. As you can see in the diagram, there is a central cable, and this cable is known as the backbone of the topology, and all the devices are connected here to this cable. Okay, so this is a simple low cost topology, but if there is a failure at one particular device, it will not affect the other devices. Okay, however, if there is a fault in the central cable in the backbone, then it is going to have an impact on the whole topology. So this you have seen that one cable will act as a backbone. So as the signal keeps on traveling farther, so some energy will be transferred into heat and the signal will become weaker. So this is one of the limitations of bus topology. And the number of cables in case of a bus topology is n, that is your drop line, plus your backbone. Okay, so this is the this is the number of cables. So as you can see in this diagram, previous one cable, that is the backbone, plus the number of devices which are connected to those, that the middle line, those will be the total number of cables. So reliability is low, security is less, and this topology is inexpensive to implement. So some are the advantages and some are its disadvantages. So this formula, you must remember that what is the number of cables in case of a bus topology. You can note this down. Next is your ring topology. Now, as you can see that all the devices are connected to one cable. Now, all of these, the whole topology, it might have repeaters in this, so that if the signal becomes weak, it is amplified again, and the starting is connected to the first node is connected to the last node, and so on. Okay, generally a ring topology is unidirectional, so the data will flow either clockwise or anti-clockwise, but there must be some possibilities where the flow of data might be bidirectional as well. So as you can see, the data with such networks is known to be traveling from one node to another through all the nodes one by one along its way, handling every single packet. So in this case, ring topology, if one device fails, then it will lead to the failure of the entire topology, because the data is traveling through each device. So if there is a failure in one device, it will have an impact on the whole topology. So this is what I was talking about. The rings can be unidirectional, having its traffic traveling clockwise or anti-clockwise. Also, it can be bidirectional. So both ways are possible. So if it is unidirectional, then the failure of one link may impact the whole topology. But if it is bidirectional, then it will not have an impact. Okay. All right, so the next type of topology is your mesh topology. Here you can see that each and every device is directly connected to each and every other device present in the network. So each node is directly connected to some or all the nodes present in the network. So this redundancy it will make the network highly fault tolerant. Okay, so as we have discussed the limitations in the previous topologies, those are overcome in this case, but the cost is very high because the number of wires, the number of ports that are being used in case of a mesh topology is very high. So due to that reason, it is difficult to implement. Okay, so mesh topology is expensive, but it is fault tolerant as well. So there are two formulas that I want you guys to note down. It is not mentioned in your presentation, the one I checked on, the one which is uploaded on Blackboard. So these type of questions are common in MCQ types, that what is the number of links in a mesh topology if there are say 20 devices or 30 devices. So you're not going to count. So this is the formula, n into n minus 1 by 2. Um, so that is the number of links, and what is the number of ports that is going to be used, that is n into n minus 1. So if we apply the formula on this diagram, number of links here is 5 into 5 minus 1 by 2, that is 10. So 10 links are used here, and the number of ports 20. Each device, 4 ports on each device are being used. So total 20 ports will be used. So I hope all of you have noted down the formula. And this one, the last one, hybrid topology. So this is a star topology with 3 bus networks. So as you can see, the central hub, the 3 bus topologies are connected to this star topology. Okay, so this is the star is the backbone and 3 bus networks are connected to it. So it is a combination. It might have a ring topology also connected to this. So when there are more than one topologies involved in an organization of devices, that is known as a hybrid topology. So if the question arises that which topology is the topology, then the answer would be as per the requirement. What is the requirement of that institution or that organization, whether they want the topology to be cost effective, if that is the priority, or security reasons are your priority. So according to that, you can choose that which topology is best according to your requirement. Okay, I hope up to this point it was clear to all of you. Star topology, wireless hub. Generally, Rohit, these topologies that I'm talking about, they are mostly wired only. Okay, we are talking about wired connections only, not a wireless in this case. Okay, so go through the presentation once again, and meanwhile, I'll have a look at all of your queries. And also search out what is the difference between active and passive hub. Okay, so most of the questions are related to the MAC addresses and IP addresses only. So a MAC address, if you talk about what it stands for, it is the Media Access Control address. Okay, and IP address is your Internet Protocol address. Now, I have already told you that MAC address is the NIC card number, and IP address is generally provided by your service provider, internet service provider. Okay, and also there is a difference that on which layer of the OSI model these addresses are working. So generally the MAC address, it works on the data link layer, and IP address, it works on the network layer. Okay, and MAC address always, it will be unique for every PC, in the sense that it will never be manipulated according to the environment. But the IP addresses, they will modify with time and environment. Okay, so MAC address for every PC will never change. Of course, by unethical ways, it might be changed, but generally the MAC address is always the same, and IP addresses will keep on varying according to the network, according to the requirement. Satyam has asked that if IP can also do the same thing, then why MAC address? See, yes, this is true that both of these are used to uniquely identify a device, but I think now it must be clear that the MAC address is the physical address of the computer, and IP is your logical address. Okay, so yes, they are used to uniquely identify the devices, but there is still a difference because IP addresses are for networks. Okay, IP address is provided by the internet service provider, while MAC address is provided by the NIC manufacturer. MAC address is always assigned to the NIC in a computer. But the network interface card, see, every network interface card has a unique number to it. Okay, unique identification number. That number only is known as your MAC address. Okay, so one of you has answered active hub is a multi-port repeater and can amplify the signals, and passive hub is just a connector which connects the wire from coming from other devices. Yes, that is correct. So active hub is the one which amplifies the signal, and passive hub does not amplify the signals. It is just a connector. L2 and L3 switches. Sanskriti, was it mentioned somewhere in the previous presentation? Or are you just L2 and L3, basically L stands for layer, layer 2 switch and layer 3 switch. Okay, the layer 2 switch, it only transfers, it only switches the packets from one port to another, while the layer 3 switch, it is capable of both switching as well as routing. So that is the difference between L2 and L3. MAC addresses help in simply identifying the device. IP address identifies the connection of the device. Yeah. Ritu has asked, what information does MAC and IP provide? So yeah, that is your answer, Ritu. MAC address is for identifying the physical address of the device, and IP address is for the logical address of the device. Identifies the connection. आयुष शर्मा, क्या क्वेश्चन था बच्चे आपका? Can we change our IP addresses? I think using different proxy servers, it is possible to change your IP addresses. Can we track our stolen laptops through Mac? Yeah, changing IP is possible using VPN. So can there be more than one MAC address of a single device? No, one network interface card and only one MAC address. No, it is not legal, Rohit. It is not legal. Okay, and there was this question. Yeah, tracking stolen laptops through Mac. It will be possible only if the device is connected to the same network. You cannot have more than one NIC in a computer. Okay, so I think answered all the questions now. I think at this point you guys have started talking to each other only. I'm not understanding which one is your query and which one is the answer. So yeah, changing IP addresses is possible, but it is not legal. And you can only have one MAC address for one device. More than one MAC addresses is not possible. Okay, so now I will create a poll. I want all of you to participate. Okay, please participate in the poll. Yeah, IP addresses are generally allocated dynamically, so they will keep on changing until and unless you're using a static one. Static IP will not change, but the dynamic IPs will keep on switching time to time. Which of these is a basic network topology? That was the question. So the correct answer is ring here. Point to point is a type of connection. Okay, whether the devices are organized in point to point manner or multi-point. All right. So ring topology is the correct answer. You can exit the session now. Thank you very much.